The golden ratio. Is it really nature's secret code? You've probably heard of it. It's been called everything from a divine blueprint to the secret of all beauty, a code that's supposedly hidden in nature itself. So the big question is, what is it really? I mean, think about it for a second. Is there a secret code to the universe? It's a huge question, right? Is there some kind of fundamental pattern, a hidden blueprint that shapes, I don't know, everything, from the swirl of a galaxy all the way down to a shell on the beach? It's a question that has captivated people for centuries. And for a lot of people, the answer to that massive question is, well, it's a single, almost mystical number. You might know it as phi, or the divine proportion, or most famously, the golden ratio. It's been sold to us as the key to perfect beauty, a fundamental building block of the natural world. But is it really? Okay, so before we can start separating the real science from the myths, we've got to understand what this number actually is. So let's peel back the curtain and look at the math behind all the magic. So this is the OG definition, the one first laid out by the ancient Greek mathematician Euclid. Now, he called it the division in extreme and mean ratio, which, yeah, I know, sounds super intense. But trust me, the idea itself is actually, well, it's beautifully simple. Let's just break this down. Imagine you have a line. You split it into two pieces, but not equal pieces. A long one we'll call A, and a short one B. Now, here's where the magic happens. The ratio is golden when the whole line divided by the long part is exactly the same as the long part divided by the short part. It's this perfect kind of self-referential proportion. And when you actually solve for that ratio, this is the number that pops out, 1.6180339, and on and on. And just like its famous cousin pi, phi is what we call an irrational number. That means these digits go on forever and ever without ever repeating. You literally can't write it down as a simple fraction. Okay, but here's where things get really interesting. Phi has this super close relationship with another mathematical celebrity, the Fibonacci sequence. You've probably seen this one before, right? You just add the last two numbers to get the next one. It looks so simple, but it's hiding this amazing secret connection to phi. Now, check this out. Look what happens when you take any two numbers in that sequence right next to each other and divide them. At first, it's just kind of close. But as you go further and further down the line, the result gets closer and closer and closer to phi. It's like it's slowly but surely homing in on that magical 1.618 number. All right, so the math is definitely cool, I get it. But where does this supposed secret code actually show up in the real world? Well, let me tell you, one of the most powerful and scientifically proven examples is hiding in plain sight, in the head of a sunflower. Seriously, think about this for a second. This is a real high-stakes problem for a plant. If you're a sunflower, you have to pack as many seeds as you possibly can into a limited space. And you got to do it so they all get sunlight, and you can't leave any big, wasteful gaps. So, how on earth do you solve that problem? Well, let's think about what doesn't work. Imagine a plant adds a new leaf or a seed at a simple angle, like a quarter turn every time. You just get 4 straight lines of seeds, with these huge empty gaps in between. Super inefficient. So to avoid creating those lines and gaps, nature needs an angle that never lines up neatly. It needs an angle based on the most irrational number out there. And you guessed it, that number is phi. And this is what leads us to something called the golden angle. It works out to be about 137.5 degrees, and yep, it's derived directly from the golden ratio. So when a plant uses this exact angle to turn before placing each new seed, they spiral outwards in this perfect pattern that just never overlaps. It packs them in with absolute maximum efficiency. It is an incredible, elegant solution that evolution came up with. And you know what the result of this simple golden angle rule is? Spirals. In fact, next time you see a sunflower, try this. Count the spirals going clockwise, and then count them going counterclockwise. I'll bet you that you'll find the numbers are almost always two neighbors in the Fibonacci sequence. And that's not a coincidence at all. It's a direct mathematical result of that growth pattern. Okay, so the sunflower is a legit, incredibly strong, real-world example. No doubt about it. But what about all the other claims we hear? The ones about the pyramids, the Mona Lisa, even our own bodies. Let's put on our skeptic hats and see how those stories actually hold up. All right, let's start with a big one, the Great Pyramid of Giza. For decades, maybe longer, people have claimed that the ratio of the pyramid's height to its base, you guessed it, perfectly matches the golden ratio. I mean, it's a great story, right? Connecting this supposedly perfect number to one of the greatest achievements in human history. But here's the catch. As mathematician George Markovsky points out, you have to remember that measuring a giant, ancient, weathered stone building isn't exactly precise. I mean, where do you start your measurement? Where do you end it? The surfaces are all bumpy and eroded. The truth is, with so many possible places to measure, you can pretty much always find two lengths that are kind of close to that 1.6 ratio if you look hard enough. So, what's the verdict? Yeah, it's a myth of measurements. The simple, hard fact is there's zero historical evidence that the ancient Egyptians even knew about phi, let alone used it in their designs. This whole connection seems to be a modern invention, a classic case of people finding a pattern because they were already looking for it. Okay, fine, the pyramids are out. But this has to be real, right? I mean, the Nautilus shell, it's become the absolute poster child for the golden ratio in nature. You've seen it everywhere, book covers, posters. It's the iconic image of mathematical beauty in the wild. Well, about that. Here's the truth, straight from Stanford mathematician Keith Devlin. He explains that yes, the Nautilus shell is a logarithmic spiral, which is super cool in its own right. It means it grows in a very predictable, constant way. But the actual ratio of that spiral, it's just not the golden ratio. As he says, pity, I know, but there it is. It's a different, but still beautiful spiral. So there you have it. Another one bites the dust. The verdict? A misidentified spiral. It's really just a classic case of mistaken identity. We see a gorgeous spiral, we've heard all about this golden spiral, and our pattern-seeking brains just leap to connect the two, even when the math isn't actually there. So this brings us to the final and honestly maybe the most interesting part of this whole story. If so many of these big claims are just myths, then why are we so obsessed with this number? Why do we want to see it everywhere? At the end of the day, the answer is pretty simple. Our brains are hardwired to find patterns. It's a survival trait. It's why we see faces in the clouds or animals in the stars. And once we learn about a cool, supposedly perfect pattern like the golden ratio, we can't help but start looking for it. And of course, we find things that are close enough, which just confirms what we wanted to believe all along. So I want to leave you with this final thought. The golden ratio might not be some secret, divine code that governs the entire universe. But does that make it any less beautiful? The real science, the story of evolution figuring out that the most irrational number is the perfect way to pack seeds efficiently, honestly, isn't that an even more amazing story? Knowing the truth doesn't take away the wonder. If anything, it gives us a deeper, more authentic reason to be completely amazed.